Hi guys, have you ever wondered how your computer knows what to do when you click an app or why different devices run different software? Well, that's where operating systems come in. Okay, now let's start. First, what is an operating system? An operating system is a system software that manages computer hardware, software, resources and provide common service for computer programs. For example, Windows, Mac OS, Linux, Android. Next, function of an operating system. What is function of an operating system? The first, process management, memory management, and file management. Next, security and access control, and device management. Last, user interfaces. Next, we see types of operating system. We have 7 types of operating system. Let's see: multiprocessing OS, network OS, batch OS, time sharing OS, embedded OS, real time OS, distributed OS. These are the types of operating system. Next, we see the process management. What is the process? The process represents an occurrence of the program being executed. It is the code of the program, current activity, and all resources needed to run, such as a CPU, time, and memory. Every process is managed by the operating system, which monitors state. For example, running the program or waiting or terminated. Okay, now see about the thread management. The difference between of process and thread. First, in process, that have separate memory spaces, but in thread, we have share memory with other threads. In process, they have higher overheaded, more resources. In thread, that have lower overheaded, fewer resources. In process, need IPC to communicate, but in thread, they have direct communication with the process. In process, concurrently independent execution, but in thread, execution within a process. In process consumes more time to creation, but in thread, faster creation. Next, we see about the memory management, RAM and virtual memory. RAM. What is RAM? RAM is a random access memory. RAM is the primary memory and fast memory used by the computer to store the data and instruction that the CPU is actively using. It is a volatile memory, meaning data is lost when the system is powered off. Next, the virtual memory. Virtual memory is the extends the available memory by using a portion of the storage drive to stimulate the extra RAM. When the RAM is full, less used, data is temporarily moved to a space on the storage drive, allowing applications to run without running out of physical memory. And next, we see about the deep into virtual memory. Virtual memory is a memory management technique that uses both physical RAM and disk storage to extend the available memory. It allows the system to run larger application or multiple processes simultaneously by swapping the data between RAM and the disk as needed, providing the illusion of larger memory space. Importance of virtual memory: efficient resources utilization, isolations, and security. Next, we see swapping versus packing. Swapping means loads entire process in memory, runs it exit. It's slow process, pays to full. Packing run all process concurrently, taking only piece of memories. Finer granularly higher performance. Packing complete separation between logical memory and physical memory. Large virtual memory can provided on a smaller physical memories. Next, we see about the file system management. File have 8 types. The types are text file, binary file, image file, audio file, video file, system file, document file, and compressed files. Now we see about the operations. First, create, open, read, write, delete, rename. First, create to create a new file in the file system. Open to access an existing file or reading, writing, or both. Read to retrieve the data from a file. Write to add or modify data in a file. Delete means to remove a file from the file system. Rename to change the name of a file. Next, we see about the device management techniques. What are the techniques? Polling, interrupts, DMA, spooling. First, polling. The OS regularly check the device status. Interrupts. Device notify the OS when they require attention. DMA means direct memory access. The direct memory access devices transfer data directly to memory without CPU involvement. Next, spooling manages tasks by queuing them for execution. For example, print spooling. Next, we see about the input devices. The input devices are used to provide data and control signals to a computer. For example, in keyboard for a text and command input, mouse for pointing and clicking, scanner to digitalize physical documents or images, microphone for audio input, camera for capturing the images or videos, touch screen allow direct interaction with the screen like smartphones and pad, that all. Next, joysticks, game controllers for gaming or specialized control. Next, output devices. Output devices are used to convey information from the computer to the users. Monitor, display visual informations. Printer, produces physical copies of digital documents. Speakers, outputs audio. Projector, display visual content on large screen or surface. Headphones, for private audio output. Let us see about the UI, user interface. The user interface of an operating system provides a medium for users to interact with the computer and the resources. It enables communications between the user and the system, the execution of the commands, navigation, and management of tasks. Let's see about the types of user interfaces. First, command line interfaces, graphical user interfaces. What is command line interfaces? Command line interfaces is text-based interfaces where users types commands to perform operations. Graphical user interfaces means visual interfaces using windows, icons, menus, and pointers for interaction. Now we see about the mobile operating system. First, Android, iOS, Harmony OS, BlackBerry OS. In Android is developed by the Google based on the Linux kernel, and iOS developed by the Apple based on the Unix, and Harmony OS is developed by the Huawei. For features designed for IoT devices, supports smartphones, tablets, and wearables. BlackBerry OS is developed by the BlackBerry. Features business-oriented secure messaging. The future of operating system is shaped advancements in technology, user demands, and the need for greater efficiency security. Next, cloud-based operating system. A cloud-based operating system is an OS designed to operate and interact with cloud environment, relying on web-based services and virtual resources rather than local hardware. Example of cloud operating system is Google Chrome OS, Microsoft Cloud Shell, AWS Workspaces, Cloud Ready acquired by Google. Next, we see about the case study. Windows operating system. In Windows OS is a widely used operating system developed by the Microsoft since first release in 1985. Windows has evolved to become a dominant player in the OS market, catering to personal, enterprise, and server environment. Overview of Windows. Windows developer is Microsoft Corporation. The Windows first released on November 20, 1985. The first version is Windows 1.0. Latest version of Windows 11 as of 2025. Supported platform x86, x64, ARM. Now we see Linux operating system. Linux is an open source, Unix-like operating system kernel that has become the foundation for various distributions. The overview of the Linux. The Linux creator or Linus Torvalds initial release in 1991. Kernel type with modular capabilities. The license General Public License GPL. Platforms x86, x64, ARM, PowerPC, RISC-V, and more. Popular distribution: Ubuntu, Fedora, Debian, CentOS, Alma Linux, Red Hat Enterprise Linux.